I think that beer.
That's the one that,
That's a normal.
yeah, see, that's even worse.
What do you mean? Plain donuts are fire, especially
Plain
fresh-
donuts are fire.
freshly baked plain donuts are
No,
the best
that's
donuts
not.
ever. That's chocolate.
Well, it's like, I'm not-
Donuts.
Donuts are the best one.
You take more than one if there's leftovers, absolutely. So just, you can get up and help yourself
Oh,
to whatever you want. Oh, boo.
it wasn't me.
All right. So I'm really proud of you guys' progress this year so far. We got like 7 weeks left until the AP exam, and I know we can finish strong, and everyone here is going to get a 5. I really feel that. So hope you do too. All right. So questions on Unit 8 personal progress checks? Anything you can ask? Yeah.
This isn't necessarily on the progress checks, but can you go over what we did like 2 days ago, like on Monday with like,
Well, if you wanted to just go over this one.
yeah, that's fine.
So question 7 on part B,
7 on
on part B,
this part B or this?
the multiple choice question.
All right. So this one. Question 7. Okay, it says, is this what we did 2 days ago? Is what we're talking about? Let R be the region in the first quadrant
Yes.
bounded by the graph of that and the line x equals 1 and the x and y axis. R is the base of a solid whose cross section is perpendicular to x axis with semicircles. So this is what you're talking about. Okay. So the idea is to get a decent sketch of the figure, of the base of the figure. So this is going to be 4 e to the x plus 2. It's basically an exponential function up 2 units. Okay, so it's an exponential function, but it crosses through the x-axis at 2, or at 3 rather, instead of at 1. Right, so it kind of looks like this. And then x equals 1 is just that line right there, right? So that's the base of the solid, right here. And then cross-sections perpendicular to the x-axis are semicircles. That means that coming out of the board, it would be a semicircle. It kind of goes like that, coming up out of the board, and then the whole way. So it's almost like a dome-shaped building type thing, right? So in general, the formula for volume, if you know the area of a typical cross-section, is the integral from 0 to 1, because that's along the x-axis, of the area of a typical cross-section. So the area of a typical semicircle is 1/2 pi r squared, right? So this is 1/2 pi r squared dx. You just have to figure out what r is in relation to x. R is half the height of the function, right? So this is going to be the integral from 0 to 1 of 1/2 pi times half the height of the function, or e to the x plus 2 squared dx. Well, this is the answer. Now you just have to figure out which one actually gives you the correct answer when you do the integration. So if I was to integrate this, the first thing I would do is I'd combine all the constants and just push them outside the integral. So this constant is actually 1/4 because it's being squared. Or another thing you could do actually, what I would probably do actually is just distribute that to make this a little bit simpler. So this ends up being the integral, or pi over 2, times the integral from 0 to 1. And if I distribute that 1/2, I get 2e to the x plus 1 squared dx. Okay, I can see why this one's a little challenging. How do you integrate that? Yeah, you have to FOIL it out. There's really no other way to do this other than FOILing it out. So this ends up being, I'm going to go up here, pi over 2, integral from 0 to 1. If you FOIL that out, you get 4 e to the 2x. That's 2e to the x times 2e to the x. And then you get plus 4e to the x plus 1. Everybody okay with that FOILing? So this ends up being pi over 2 times the integral of 4e to the 2x is 4e to the 2x divided by 2. The integral of 4e to the x is 4e to the x. And the integral of 1 is x. Evaluate from 0 to 1. Okay? So I have pi over 2 times, if I substitute 1 in, I get 2e squared plus 4e plus 1. And if I substitute 0 in, e to the 0 power is 1. So this ends up being minus 2 plus 4 plus 0. Okay, so I can combine all the constants. I get pi over 2 times, sorry, I'm scattered around a little bit, but pi over 2, this ends up being 2e squared plus 4e, and then you have 1 minus 6, minus 5. So it has to be choice A. They just distributed the 1/2. So the answer is A. That one took a little bit of time. That was a time-consuming problem. It was non-calculated question, so you only have 2 minutes per problem. That took us longer than 2 minutes. But like I said, I mean, you'll gain time in other problems. Any questions on that? You kind of understand how it works?
Yeah.
So these cross sections might be semicircles, they might be squares coming out, they might be triangles. But in general, like what goes here is the area of a typical cross section. That's perpendicular to the axis of integration. Like if you're integrating from over x values, and these are functions of x, then its cross section is perpendicular to that area of a cross section. Okay. All right, what other questions do you have? Yeah.
Did you say something part of it?
Part A. Sure. Let me erase this. What a coincidence. We're having a part A. That's funny. All right. Part A. That's number 6. If the average value of the function is 3, then what is the value of this? Okay, so what's the formula for average value? So this would be 1/4 times the integral from 2 to 6 of f of x. Yes. They're telling us that that's 3. Right? So that means that the integral from 2 to 6 of f of x is what? 12. Multiply both sides by 4. So if you're trying to find this integral is just really 5 times the integral from 2 to 6 of f of x, plus the integral from 2 to 6 of 2 of dx, right? You could split up using properties of integrals. So this ends up being 5 times 12 plus 2x from 2 to 6. So this is 60 plus, if you plug 6 in, you get 12 minus, plug 2 in, you get 4. So it's 72 minus 4 is 68. Okay? What else? John? Yeah. On the same set?
Yeah.
3. What's the area of the region in the first quadrant bounded on the left by the graph of x equals y to the 4th plus y squared, and on the right by the graph of x equals 5y? Okay, so what's interesting about this problem is it's functions of y, right? So they're telling us we're probably going to have to use that functions of y and y values as limits of integration. Okay, so the first thing that I would do is try and graph it if I can. Okay, so I'm just trying to think like, do I know what the graph of y equals x to the fourth plus x squared looks like? I mean, I know generally that fourth degree polynomials look like this, right? Or they might be even something like that, where one of the things isn't quite formed, or something like that, right? So if it looks like that generally, and I set this equal to 0, I get x squared times x squared plus 1. The only root of this polynomial is 0, because this root would be imaginary, right? So the only root of this polynomial is 0. That really doesn't tell me a lot. But maybe it really doesn't matter. All right, so since this is x equals y to the fourth plus y squared instead of y equals x to the fourth plus x squared, it's going to be something like this. I mean, I don't really know exactly what it looks like, but maybe it goes something like this. Who knows? Something like that, right? It only has one root. I know that. So it has to be something like that. And then on the right, x equals 5y is just a line, right? If I wrote this in terms of y equals x over 5. It's a line of slope 1/5, right? That passes through the origin. So it kind of goes like this. Maybe like that's the region that we're referring to right there. Okay. The important part of drawing a sketch is just so you know like what the top function is and what the bottom function is. But even if you get that wrong, it's going to give you the negative of the answer that you're looking for. So it doesn't matter that much. The next thing we need is points of intersection. So you can do it algebraically sometimes, but it doesn't look like that's going to be possible here. So how do you find points of intersection here? Yeah, this is a calculated question, right? So that's what I'm going to do. I'm just going to set x to the fourth plus x squared. Oh, that's not good. Delete. X to the fourth plus x squared. And then I'm going to set that equal to 5x and see if I can get a solution. So I'm going to graph them. I'm just going to do zoom standard. And then I'm just going to do second calc intersect. I mean, I know one point of intersection is 0, so I don't have to do that one. I do this other one. So first curve, second curve, guess. So it's 1.516. That's actually this y value. It's this y value right here. 1.516. But remember, when you're doing it on your calculator, that's now saved as x. So on my calculator, I'm just going to do math 9, the integral from 0 to x, and the integrand is going to be the line, which I already have entered as y2. So I'm going to go variables, y variables, function 2, minus the fourth degree polynomial, which is variables, y variables, function 1, dx. And you should be really comfortable using your calculator to do integrals. Don't try and do this by hand. Yes, you can do it by hand, but it's very time consuming and it's a waste of time. So the answer is 2.983. It has to be choice A. Okay? Another thing, like if you knew kind of what this picture looks like, you could rule out C and D. That's way too big for like a region enclosed by two curves that look like this. Yeah.
What about the calculator? Can you just show us again how to like save something as something other than x?
Yeah, so say I wanted to save this. It's called store. It's right there. You just press store, and it'll save that previous result. And then you can save it as anything you want. So like I could save it as B or something. I would just go alpha and then 6. So I'm saving it as B. And then every time I type in B, like if I did like, for example, B plus 2 or something, it should be 4.982. Press enter, and that's what it is. And it'll be saved like that forever. Even if I clear my screen, if I like type in B again, it's still that number. The only way it gets off of that number is if you like totally reset your calculator's memory, or if you just say something else as B. Okay. What other questions about? Yeah.
This isn't really one from progress checks, but could you explain how to identify within a problem where you need to like integrate using the y-axis, not the x?
Yeah. In an area problem, this is a good example because they give you functions of y rather than functions of x. So in an area problem, if they give you functions of y, and it's not easy to solve for x, like it wouldn't be easy to solve this for y, right? Like to put it in terms of x, like that wouldn't be easy at all. That one, yeah, that's not hard, but this one is very hard to solve for y rather. So that's a big hint right there, if they give you a function of y. Another way you can tell, sometimes they'll give you functions of x, but it's easier to do it in terms of y. And that's if the, trying to think how to describe it. If by doing it in terms of x's, you'd have to do it in 2 pieces, but by doing it in terms of y, you can do it in 1 piece. Like if you have a region, like we had a region that was shaped like this, remember? And if you did this in terms of x's, it's not that hard, but it requires like 2 pieces and 2 different integrations. Whereas if you do it in terms of x, like functions of y, then it's just 1 top, 1 bottom, and it's 1 piece, right? So that's in terms of area, how you can tell whether you do it in terms of y's or x's. And if you're doing it in terms of y's, the limits of integration have to be y's. If the function has x's in it, then the limits of integration are x's, okay? So that's for area. For volume questions, you know you have to do it in terms of y if the cross sections that you know about are perpendicular to the y-axis. They're going this way. If the cross sections you know about are this way, like semicircles, or you're rotating around a horizontal line like the x-axis, then it's definitely functions of x and x values. But if it's a rotation this way, or if they're telling you it's cross sections perpendicular to the y-axis, or squares or whatever, then you know you have to use y's in that case. Does that help? Okay.
Well, every time that you have rotated around a vertical line, that will always be.
Has to be a function of y, and y values for limits of integration. There's no way around it. I mean, there's another method that I'm not teaching because it's actually on the Calculus BC test. I'll describe it for a second, just so you get an idea like about how it works. But like, say you have a parabola that's rotated around the y-axis, so you end up with like this little cup-shaped thing like that, right? One method of finding the volume of this is called the method of cylindrical shells. And basically what you're doing there is you're splitting this up into like concentric cylinders. You know, like each one of these little blue cylinders, you could like unroll and end up with like a thin little rectangular prism like thing if you took any one of these cylinders and unrolled it. That makes sense? So the method of cylindrical shells is like taking each one of these little cylinders, calculating its volume. Like this is like, the thickness is like dx, right? The height this way is like the difference of the 2 functions. And the height this way is like 2 pi r, right? Because it's the radius of the thing. So it ends up being like, this is like 2 pi x actually, because x is the radius at that point. And then this ends up being like f minus g if there's 2 functions. You know what I mean? So that's called the method of cylindrical shells. It used to be on the AB exam, but they switched it a few years ago to the BC exam, so I just don't bother with it anymore because I don't want to confuse people. But that's the idea. So for us, yes, every time you're rotating around a vertical line, definitely it's easier to just use the method of washers here. Okay. All right, what else? Maybe we want more food? What else? Nobody wants to be the first one. Good job. Don't knock them over, Josh. Don't knock them over. Eden. Josh. All right, you're grounded. All right, what else?
You got a number 9 on that.
Sure.
It might be on.
When I was grounded when I was little, grounded for me, for my parents, was sitting on my bed, like for a whole day. I wasn't allowed to get off my bed. They would bring me food on my bed. It's horrible. You guys are lucky. You're lucky. All right. The velocity of a particle moving along the x-axis is given by this formula, which the following gives the total distance traveled. How do you calculate total distance traveled if it's not a calculator question? What if it was a calculator question? What would you do? I wouldn't graph it. I wouldn't graph it. Yeah, if this was a calculator question, just take the integral from 0 to 3 absolute value of v of t. Boom. Done. And you can do that on your calculator, right? Your calculator has absolute value. What if it's not a calculator question like this one? What do you mean? Yeah, I mean, basically what you have to do, I think this is what you're saying. The v of t might look something like this, right? Between 0 and 3. You have to determine when it crosses the x-axis so that you can then take the integral of this piece plus the negative integral of this piece, because you want to calculate this area here, plus the integral of this piece. You know what I'm saying? So that's what you have to do. You have to figure out where this crosses the x-axis and then split it up into so many different integrals, right? And you don't even need to know when it's above and when it's below. You don't have to do a sign chart necessarily. You just need to really just take, like, if the function looks like this, you really just need to take the absolute value of the integral on this interval, plus the absolute value of the integral on that interval, plus the absolute value of the integral on that interval. You know what I mean? So you don't even really need to know when it's positive and negative. You can just, if it ends up being negative, just change the sign. Okay, so that's what I'm going to do. I'm going to set this equal to 0 to determine like where I need to take integrals separately. So e to the t minus 1 equals 1. How do you solve that? Yeah, okay, so there's two ways to think of this. You can either take the inverse of e, which is ln, in which case you get t minus 1 equals ln 1, or 0, so t equals 1. Or you could just think if e to some power is 1, the only way that works is if it's e to the 0 power. So then you could just like reason through it, t minus 1 equals 0, and t equals 1, either way. Okay, so I need to take two integrals here. I need to take the integral from 0 to 1, e to the t minus 1 minus 1, plus the integral from 1 to 3, e to the t minus 1 minus 1. I forgot my t. Okay, that's it. So the integral of e to the t minus 1 is just e to the t minus 1. So I have e to the t minus 1 minus t, 0 to 1, plus e to the t minus 1 minus t from 1 to 3. absolute value. So if I substitute in 1 here, I get e to the 0, which is 1, minus 1, minus, if I substitute 0 in, I get 1 over e. Wait a minute. I don't have to do all this. You have it right here. Yeah. So, oh, okay. So how can you tell if it's this one or this one? Definitely not C, and it's definitely not A. How can I tell if it's B or D? I wrote this. This is either this or this.
Well, if you keep doing what you're doing, find out if that section is greater than or less than, like, if you got rid of the absolute value sign first, you would find out if it was greater than or less than 0.
Okay, so that's one way to do it. I could actually like evaluate this integral and find out if it's positive or negative. If this one's positive, then it has to be this one. If this one ends up being negative, then it has to be this one, right? So that's one way to do it. Now, what if I don't want to waste all that time? Like I wasted a lot of time like doing all this. I didn't need to do any of that. Just from here, without evaluating any integrals, how can I determine if it's B or D?
You could do like a sine chart of the velocity.
Yeah, I could just substitute a number into the velocity and see if it's positive or negative. Like if I substitute in 0, for example, I get 1 over e minus 1. 1 over e is like 1 over 2.7. Minus 1, that's definitely a negative number. So it has to be this one. It has to be B. Does everybody understand that? All right, what else? But don't forget, if it's a total distance traveled question and it's a calculator question, it's really easy. Just absolute value, velocity, and integrate it. The absolute value takes all that stuff and makes it positive, all the negative stuff. What else? Anything at all? Nah? Nah, dog? Nah, fam? Yeah,
We just like, kind of go over just again what we did yesterday, like with the washers.
sure. How about this? What if we wanted to calculate the volume of a donut? Okay? And let's suppose to do that, we're taking the circle whose equation is, well, let's draw it first. Let's say that we're taking the circle right here of radius 1 and rotating it around the x-axis. We want to calculate the volume of that donut. Okay? So the equation of this circle is, its center is at 0, 2. So this is going to be x squared plus y minus 2 squared equals 1. That's the equation of that circle. How do we do that? Yeah, we could solve this for y because really we need to have functions of x, right? So you need to split this up into the top semicircle and the bottom semicircle, right? So if I solve this for y, I get y minus 2 squared equals 1 minus x squared. Square root both sides, so y minus 2 equals plus or minus 1 minus x squared, square root of 1 minus x squared. So y equals plus or minus the square root of 1 minus x squared plus 2. The plus part is the upper semicircle, and the minus part is the lower semicircle. Everybody okay with that? So now if you look at a typical cross-section of this, a typical cross-section would be, like there'd be another thing down here, right? That's the other cross-section. So it's going to be like, there's a piece of it here and there's a piece of it here in a typical cross-section, right? So it would be like a washer shape, and it looks like that. That's a typical cross section, right? So this volume would be the integral of, or from -1 to 1 of the area of a typical cross section. Well, a typical washer has an area of pi r squared minus pi squared, right? Right? Big R is like the big radius of the whole washer. Little r is like the radius of the hole, right? Well, in this case, the big R is the plus part of this, the upper semicircle, and the little r is the lower semicircle. So this would end up being, and I could take the pi out if I want to, like factor out a pi. I'm going to do that too. So this ends up being the integral from -1 to 1 of pi times big R squared, which is 2 plus the square root of 1 minus x squared, minus little r squared, which is 2 minus the square root of 1 minus x squared. And that would be it. All right, but just in general, like if you're trying to calculate the area using the washer formula, it's this formula right here. Okay, if this is multiple choice, I guarantee you one of the wrong answers is going to be this. It's going to be the integral from -1 to 1 of pi r minus r squared, or something like that. Like they're going to try and fool you into making a stupid algebra mistake. Okay, this is not the same thing as that. But that's always a choice on multiple choice for this type of question. Does that kind of help? Just in general, I mean, what you want to do is you want to visualize a typical cross section. Then you know what the big radius is, what the little radius is. Little radius is just the function that's closest to the axis of rotation. And big radius is the function that's furthest away. That's it. Yeah.
Can we do number 2 on carbon?
Yeah, multiple choice.
Yeah.
Okay. Part B, this is part A, right? I think we were doing. Yes,
Yeah.
part A. So part B, multiple choice. Number 2. So it's a calculator question. Base of a solid. Excuse me. Hot box myself. The base of a solid is the region in the first quadrant bounded by the graph of y equals cosine x in x and y axis from 0 to pi over 2. All right, so it's just like this thing right here, right? That's cosine. That's what cosine looks like in the first quadrant. Okay? And it says for each cross section perpendicular to the x-axis, you have an equilateral triangle. Okay, so this is like the hardest situation, I think, in terms of known cross sections. It's calculating the area of an equilateral triangle. So just in general, like I know the formula is going to be the integral from 0 to pi over 2 of 1/2 base times height. Like that's the area of a triangle. So this is where I would start here, right? Then you just have to figure out like how is the base and the height related to this function? I know the base is just cosine x. That's easy, right? The base of this triangle is like that distance right there, which is just cosine x. The hard part here is figuring out what the height is in terms of x, right? So just draw the pictures separately. Like if I have the picture drawn like this, and this is B, and this is H, rather, and I'm trying to express H in terms of B, there's lots of different ways you could do this. You could use trigonometry, and the fact that this is actually an equilateral triangle, which means each half of it, each half of it is a 30, 60, 90 triangle, right? So if I think about it, this is like B over 2, right? Bless you. And I know that, like if I use this angle up here, I know that the tangent of 30 degrees has to equal B over 2 over H. And I can solve this for H. It's a little messy, right? There's other ways you can do it. You can use the fact that this is a special triangle right here, right? And how is the long leg related to the short leg in a special triangle? times radical 3. Yeah, it's times radical 3. So that's the best way to do it. H is just b over 2 times radical 3. That's probably the way I would do it. This ends up being radical 3 over 2 times cosine x. You know what I mean? That's probably the easiest way to do this. Another way I could have done it is the Pythagorean theorem. Like, I know that this is b over 2, and that's h. So I could have done h squared plus b over 2 squared equals b squared, and then solve for h. I would get the same answer. Any one of these three ways would be the same answer. But this seems like the most direct way. So I'm going to do radical 3 over 2 times 1/2, which is radical 3 over 4, integral from 0 to pi over 2 of cosine squared x dx. That's the answer, whatever it is on my calculator. Does that make sense? Equilateral triangles are the hardest situation. So just pick a way and just remember kind of how it works. Like, I would prefer to do it the special triangle way. So every time this question would come up with an equilateral triangle, I just remember that I'm going to do it that way. I'm not going to memorize that it's radical 3 over 4 times base necessarily. Times b squared, because that's really the formula for the area of an equilateral triangle is radical 3 over 4 times b squared. But that's just a waste of space in my brain. But I'm going to remember like what I did to get that. And if it comes up, which it might, it's really the hardest situation, so it probably doesn't come up but every few years, but if it does come up, that's what I would do. Okay? Any other last minute questions? So tomorrow's test is no calculators, and Friday's test is with calculators. Make sure you bring your calculator. Anything else? All right. And just remember, we're like really close to the AP exam. Really. It doesn't seem like it's that close, but it's like, if you don't count spring break, it's like 6 weeks, which is like nothing, So let's just like power through, don't take anything for granted, and you guys are just gonna do great, and then we'll be totally done.
I think a piece of thing into the road.
Yeah, sure. Gotta hide these before my next class, so they don't get jealous, but I like you guys more.
Thank you, by the way.
Good job.
Sure.
Thanks for all the food, Doug.
Anybody else? Katie?
Also, you. Yeah, no, that was crazy. I can't believe that. I'm scared, but I like it. Why? You know, want to get out of there? You want that water? We'll make it like 4.